How are you doing?
I'm doing great. How are you doing?
I'm good. I'm good. Can you see me very well?
I can see you, I can hear you.
Okay, cool, cool. Yeah, how do you pronounce your name? Is it Sai? Say Sharon?
Yeah,
Okay, cool, cool.
you can call me Sai.
Sai, okay. I'll call you Sai. And my name is Isaac Kabunga. But yeah, I prefer you can call me Isaac. I think it's easier.
Isaac, thank you for accepting my invitation and accepting to be on my show.
Yeah, no problem.
So I thought to introduce you to my audience.
Okay.
So can you please introduce yourself?
Yeah, so my name is Isaac Kabunga. And currently, I'm a AWS solutions architect. Uh, what basically that means, I work with the cloud services. I deploy um, I deploy infrastructure into the cloud, and mainly I'm working with the AWS, but I'm also familiar with other platforms like GCP, Azure, and I deal with cloud migration to the cloud, and I basically try to use a well-architectured framework in AWS that I follow, and I follow all the pillars of AWS, and that includes operational excellency, security, reliability, performance efficiency, and cost optimization.
You're from?
Originally, I'm from Africa and in Uganda.
You live in?
I live in the US. I live in the USA in the state of Kentucky.
Okay. So have you worked before?
Yeah, so well, a little bit of my background. Let me, if you don't mind, I can explain a little bit of my background. My IT journey started a long time ago when I was 17 years old, when I was in Africa. Well, at a very young age, I enjoyed working with computers, so I like taking them apart and putting them back together. And at the age of 17 years old, that's when I was about to finish my high school. I started. I opened up a video library, and basically, what he was doing, I was selling CDs. I was selling music, and that's the time when uh, CD when the CDs had become like really famous. That's the time we had moved from VHS and were transitioning into the CDs, the CD-ROM. So I worked with that, and I would I would uh, I would make movies, I would make music, and put it on the CDs and sell it to my customers at the time. And I started working. I dived deep into computers, and I started installing the operating systems. So I started working with Microsoft, and I started installing Microsoft operating systems for clients. And then I started troubleshooting. I started my troubleshooting skills and started with helping our customers with viruses at the time, because internet was starting to get really famous. So they were getting a lot of viruses on their computers, and they would spread it around. So I dived deeper, and I learned how to get rid of the viruses on the customer computers. So started installing antiviruses on their computers, and then eventually I ended up going for training. I went for Microsoft training, and I did a Microsoft certification training. back home. And then 2 years later, I moved to the US. 2 years later, I moved to the US. I started my school here. I went to college here. I did Associates of Science in Computer Engineering at the time, and I got a job here working with a company. It's a German-based company I was working for, and it mainly deals with IoT. If you're familiar with IoT, in simple terms, it's Internet of Things. So I started working with that company. I worked with them for about 5 years. And at the time, I had finished my degree, so I was familiar with the databases. I was familiar with different operating systems, Linux, Microsoft. And then as I was working with my client at the time, as I was working with my client through my job at the time, I found that on premises they had a little bit of more issues that they were facing. So as I did some research around, and that had to do with the issues they were facing, that had to do with the storage, because the client who I was working for, they were dealing with the airport systems. So they had a lot of storage that they had a lot of space they needed to clear to free, but they didn't know where to put their files. So I did a little bit of more research, and after that was about in 2014, and I found out about cloud computing. And when I found about cloud computing, I dived deep into it, and I started learning about it. And then after deploying a couple of EC2 instances, I realized, you know what, this might be something that can be of a next generation. So I might need to get a deeper understanding of how the cloud computing works. So I started taking my courses. Back then, there was a cloud guru, so I took a few courses there and gained some experience working in the cloud, deploying a couple of virtual machines here and there, and then basically it brings me now to this time. I'm a AWS solutions architect. I'm 5 years in, and I've been deploying a couple of applications in the cloud. And also, I personally, I'm one of the founding members of Sarafina Sickle Cell Society, and it can be found on www.sascells.org. And I designed the website and I deployed it to the cloud in AWS. That's one of my projects I've worked on. So it's an NGO, but we're utilizing the AWS resources to minimize on the cost. Because as you know, NGOs, you don't know if you're gonna get funding or not. And since it's an NGO that's just starting up, I found that AWS would be migrating to the cloud would be the cheapest option for us, and it's been really working pretty well. And I'm willing, and with my knowledge and research, I'm willing to take on different clients and explain to them, look into their infrastructure on premises, and teach them and educate them so they can explore with the cloud services and how they can migrate to the cloud.
So you got certification?
Yes, I have a certification in AWS Solutions Architect.
So what are the services that you know that you can implement?
So by other services, you mean other services in AWS that I can implement or on other environments?
Uh, you said you worked as a solution architect.
Right.
So
Yeah.
what is that job and what you did?
So as a solutions architect, what we do, basically what I did was you go, if you have, let me say, for example, you get put on a project. Let me say the customer has a data center located on premises, and they have a couple of servers that are on site, and they are planning to migrate to the cloud. So your job as a solutions architect is to collect all that infrastructure on premises and migrate it to the cloud. So that means they can either go two ways. They can have a hybrid architecture where they keep their own premises data center, and at the same time they have services that connect to use the AWS or cloud resources in the cloud, like storage. Like for example, if they are running out of storage and they have old files that are stored on site, they can clear out the old files by migrating the files to the cloud, and then clearing out the space in the data center. They free up the space in order for their servers to have more performance. So for a job as a solutions architect, what I do, I'm going to speak to the client. They give me a little bit of more details, which is like I said, I follow a well-architectured framework, and those are the pillars of a well-architectured framework in AWS. I follow. I'm gonna look into like, if this server needs to have to be performing very well, what we need to do is free out space, increase memory, things like that, increase memory performance, make it highly available. So I would recommend a customer to move, like, a couple of space to the cloud, and then reserve his space on the data center, at the same time utilizing both services.
So you help in shifting the data from physical data center to the cloud.
Yes.
So you said the client will have some servers and they wants to shift their information, the complete data to the cloud, and so you go and you see what the client uh, have already, and you understand it. Then what you do?
Yeah. So after I explain to the client uh, what their infrastructure currently has, I'm going to go to the cloud and look at a couple of resources. So let me say, for example, they have services like they have services that require performance. Like they have a couple of servers that are slow and stuff. I would recommend them to migrate. I would recommend them to migrate to have like a hybrid architecture. By hybrid architecture, I mean they have their own on-premises data center. The servers are on premises, but then we create other databases in the cloud. So both databases are connected together while they explore. So they are utilizing both resources at the same time. And then after they are comfortable and they feel like the cloud is working out more for them, then we do a complete migration to the cloud. So that with that, we can plan on migrating the whole data center to the cloud, and then they utilize the whole resources. And that means that they are going to do away with the data center. So they don't need the physical servers anymore. What they need is access to the cloud in order for workers to be able to access the services in the cloud. And with that, there is also a design, like there is a way we can set them up as if they were on premises and working. Like for example, let me say for example, they have call centers, right? They have call centers and they are connected to the servers. They are still gonna be able to use their call centers, but this time, instead of the workers connecting physically to the computers in their own premises, this time they have access to the cloud services and they connect as if they are on premises, but this time around they are in the cloud.
So can you give me a specific example that you shift from data center to the cloud? Particular example.
Okay. Yeah. So an example I'm gonna give you is going to do with let me say for example, it's a parking system, right? It's a parking system, and they have a application where like if you're familiar with the way the parking system works, like they have like garages or parking lots which have like IoT machines, like internet machines like we're gonna call them like embedded systems. That's the word. Embedded systems, to where a car is going to drive in. They're gonna pull a ticket. They get into the garage, right? They get into the garage, and then they stay. Let me say, for example, they are gonna stay for 2 hours, and then after 2 hours, they have to come back with the ticket. They insert it into the machine. And then the machine tells them, this is how much you owe. You owe $5. The customer is going to insert a ticket, and then they're going to use their credit card to pay. They insert it in the machine, like a pay machine, for example. That's how the embedded system for parking machines works. And then the gate opens, the customer leaves. So with that kind of setup, those machines in the garage, they connect back to a data center, and that is somewhere around the garage. And around the garage, that'd be like the main office, the manager's main office, anywhere they connect. So those are transactional records, and with that kind of setup, you have things like reports that you generate, like monthly reports, weekly reports, and receipts for customers. And you have to keep track of everything as it goes on. And over time, as the transactions increase, and then at the same time, when you're working with transactions, you have to be able to store the information securely for customers, so it doesn't like hackers or any bad cyber criminals can't access it. So with that kind of setup, what you can do, since your application is connected locally back at your data center, what you can do, you can deploy a server in the cloud. You can deploy let me say, for example, I'll use a simple term, like a server would be like a EC2 instance. By EC2 instance, I mean It's called Elastic Compute Cloud. Elastic Compute Cloud. So you're going to deploy a couple of servers in the cloud, and then instead of you having those servers on premises, you're going to migrate your application. You're going to migrate your application. That's the code. By the application, I mean the code that runs your application. You're going to migrate it to the servers, to the EC2 instances you're going to launch. There can be many because it depends on the size and the capacity. It can be many you deploy in order to operate. It depends on how big your application is and how big your customers are. Like, if they are located, like, all over the world, and, you're having a lot of that traffic coming in, that means you need bigger space in the cloud. So the good thing with the cloud, the advantages of it is, if you notice that the difference between you having these servers on premises is that when you're going to do that, you have to first of all, you're going to have to hire a solutions architect like me to come on site, and then you're going to hire a couple of developers. You're going to hire a couple of IT administrators. All together as a team, they are going to work to come up with enough capacity for you, right? And this is something that is not accurate. It's not accurate. It's just a predictable figure they are going to give to you, like, oh, well, with that kind of application, you're going to need a CPU this much. You're going to need this much memory. You're going to need 200 gigabytes of storage. And then you buy all that stuff. You buy a rack. You buy a couple of servers, and then you do the installation. They do the installation, and then your application runs there. But with the cloud, the difference is these applications have these instances we're launching in the cloud, like on the EC2, they have elasticity. So as your traffic grows, by the traffic I mean your customers that log into your application, as the number increases, you can increase based on the size without you going, to go buy the stuff physically. This time it's in the cloud. All you have to do is use a couple of automation tools like Terraform, like CloudFormation, to allocate memory, allocate storage, and then you deploy your application. And after you install the application, you have enough space, and then you can pay on demand. Like with AWS, you can pay on demand as your clientele increases. You increase your space, or you can even launch serverless applications. Like you can launch serverless containers like Fargate, where they increase based on the demand of your customers. And then also your databases, you can choose them. So now with the back before, when everything was on premises, we only had one option. We had a relational database, RDS. We had a relational database, which was kind of fixed. Everything, the way you buy it at a time when, like I was explaining to you, when your developers and the IT administrators, that much storage they were able to give you, and what you bought, that's what is going to stay. So if your storage, if your clients increase and you have more traffic, that means your space, you're running out of space. And only way to increase it, you have to go back and buy more servers in order for you to accommodate the large number of clients you have. But with the cloud services, you have flexibility. You are flexible. Ask me, how are you flexible?
Yeah, tell me that.
Yeah. So with the cloud, you are flexible because not only that, the same data, the same servers you have on premises, you can still migrate them to the cloud. You can still have a relational database, but now we have different types of these databases. Like we have Amazon Aurora. Amazon Aurora is a relational database like you have that has it's compatible with MySQL, which is scalable. It automatically scales and it's managed by AWS. As a client, you don't have to worry about you managing your server. It scales as the demand increases. And then at the same time, it scales as the demand increases. And then at the same time, it's managed by AWS. So all you have to focus on, you only have to focus on managing your infrastructure to grow your clients.
So can you tell me some use cases that you used?
Use cases of the database?
Of the architecture.
Well, there are a couple of use cases like right now in the real world. Like, for example, if you look at Netflix, if you're familiar with Netflix, the application, right? Netflix, they are using AWS. So everything as the application, Netflix, because it's big and it's global. And one thing it is with Netflix, since it's global, it's easily accessible all over the world. The application, you can get it in most countries in the world. And reason being, they are using AWS, and at the same time, they are using containers that scale like DynamoDB, and they are using databases that scale like DynamoDB. It scales as big as it can be, and they use Redshift. They use databases like Redshift, and they use services like Lambda functions that are serverless, So a couple of their applications, when they run as the application, it's run to a point that as the margin of their users grows, their database in AWS scales based on the user. And then if the margin reduces, the database shrinks back up. So it has the ability to scale in and scale out. So there are two advantages with this. First of all, you have the ability to increase to scale vertically. By that, I mean you can increase your CPU, you can increase your memory, and then at the same time, you have the capacity to scale out, to scale horizontally. That means like you can increase more databases as the demand decreases. So instead of just adding CPU and memory, you can still even add more databases. So Netflix is a perfect example of one of the customers utilizing the AWS resources. You have Uber. They are using AWS. I think Uber might be using somebody else. It might be GCP. They are using Google Cloud Platform, and then you have DoorDash. DoorDash is also another one that's using AWS, and they use it for storage mainly.
Okay, so what are the core services that are important to know?
So the core services that are important to know, it depends on how you're looking at it. Are you looking at it as a developer who's trying to learn, or are you looking at it as a customer? So the demand for the services depends on what. So that's where, again, a solutions architect comes in. Like, my profession, that's where I come in, because first, a client has to tell me what services they are offering to their customers. I need to get that information, that detailed information. Once I know that information, I'm going to compare the two and map them and map the resources from AWS to recommend to them to use or to deploy for their application based on their needs for the customers. So like for example, I'll go very simple. Like for example, if you're trying to host, let me say for example, you have a website, a static website, right? It's a small website, and it doesn't. It's a small website. All it does is a customer visits the page, they get the information like a phone number, an email, things like that. Maybe a simple form where they fill out their information, and then they send it to you via email, and then you receive an email like that. Their infrastructures, like you can use serverless architectures like Lambda. Like that's a service in AWS called AWS Lambda. What it does, Lambda is serverless. That means you can use that service to launch. All you have to do is deploy your code into Lambda, and then Lambda is going to run your code every time a customer visits your website and they type in your domain name. That's when the application Lambda is triggered that way. It's triggered, and then it opens and pulls the information it needs, like storage, like for example, if you need like I said, like filling out a form and stuff like that, that's something that's stored like in a S3 bucket somewhere. S3 is also another service in AWS, and that has to do with storage. And with storage, there are a couple of things also maybe I forgot to point out. There are with the cloud infrastructure, you're looking at two things. There is compute, a couple of things. There is compute, there is storage, there is database. Those are the three things you're looking at. So with compute, you're looking at EC2 instances, you're looking at containers, ECS, EKS, and then with EKS, Elastic Kubernetes services, that's agile. Like you have it on all environments. So you have it on GCP, Google Cloud Platform, you have it on Microsoft Azure, you have it on IBM Bluemix, other cloud providers. Also, it's compatible with them. Like they have also Kubernetes services. So you can launch Kubernetes containers on other platforms, not just AWS.
So is it important for a solution architect to know coding?
For a solutions architect, it's not necessarily, you don't have to know coding. You don't have to know coding because your job mainly is to pick a well-architectured framework. So like with that, I'm saying you have to be able to figure out the best services for your customer. Like these things come with cost. So like for example, you have to look at the cost optimization. If I'm picking these services, let me say for example, you're gonna go ahead and pick this type of database. Like if I'm gonna pick a relational database and use it, and I allocate this amount of space, is it gonna be able to save me money in the long run, or is it gonna be income more charges in the long run? Do I need to to reserve my instances. Like, do I need to pick on-demand instances? Do I need to pick reserved instances or sparse instances? Things like that. So for a solutions architect, you should be able to know what architecture and what framework to use in order to save your customer on the cost. And then it has to be highly available, and it has to be resilient to where it's fault tolerant, like, it's able to withstand faults at any time. Like, let me say, for example, one of my data center that hosts my services goes down. Are the customers going to lose access to the services I'm offering? Like a blackout, for example. Like, there are situations like where you visit a website and the website is showing you, like, the URL is giving you an error. Basically, you're getting error 503, like, it's not found. Issues like that. That means, like, something happened to a data center or location. So a solutions architect needs to be able to know that I need to pick a architecture that's highly available. Like, if one data center goes down, there is another data center can be able to have it's called a standby replica, like, a standby database, to be able to work as a secondary from the primary database. They have to know that, and then at the same time they have to know what storage to use, what type of storage, what type of storage to use, and they also need to know when to transition through storage classes. Like Amazon S3, it has like a life cycle policy, where you have Amazon S3 has different classes in it. It has S3 standard. It has S3 infrequent access. It has S3 one zone infrequent access. It has intelligent tiering. It has S3 glacier. So you have to know when to transition between those storages in order to reduce on your cost, because charges apply based on how often do you access that storage. So for files that are, for archive files, I would recommend, as a solutions architect, I would recommend for you to move all the files more than 90 days to like S3 glacier deep archive, because they are going to be scored for longer term. And then for files that are accessed more frequently, like on a web application, those ones I'll keep them in S3 standard, because they are accessed more frequently, and that is flexible. It's it's cost optimistic, that it makes you reduce on the cost of a customer. Like, in the long run, they will see that, like, they'll see a difference from you being keeping this stuff on premises, how much you incur, and then the difference when you migrate to the cloud and you use these kind of storage types, and then you transition through their life cycle and store archive files where they're supposed to be, and frequently accessed files where they are supposed to be. So as a solutions architect, you should be able to do that. You should be able to pick your services based on the cost, reliability, performance, efficiency, and operational excellence. So with what you were saying about, it's always good for a solutions architect to know a couple of programming languages because it makes you, it makes you agile, it makes you more flexible when you're working with it, but you don't need it. You don't require it because unless you're going to do a little bit of more hands-on and work with the developers and do that, but necessarily a solutions architect, you don't need to know programming. You can come from a different career path and learn how to become a solutions architect.
So, if possible, in the next session, can you show the core services, how it works by implementing it?
Yes, yes, I can deploy a couple of services and show you how to do it. Actually, today, I don't know if yeah, I mean, we can schedule a time when we have enough time, and then I can deploy a couple of services, or I can I can I can write the code. I can write a code or pull a code from somewhere, and then we deploy it and see how it works. Yes, and I should be able to share my console, and then they should be able to follow through if they want to follow through. Whoever is listening out there, in the next session, yes, it's possible.
So, at last, do you have anything to say to the people who are solution architects and who are going to be solution architect? Do you have anything to say who are watching and who are listening to you from anywhere on this planet?
Yeah, well, anything I would say, like, it's always helpful. Yeah, it's always helpful for somebody to come in this field, especially if you have like a networking background or you have, well, any IT background is always good. You're familiar with computers, especially like it's always good if you know your way around your database, the database management, uh, any of the database programs like MySQL, it's always good. Or if you have a networking background, it's always great that you have it. Also, if you know a couple of programming languages, it is good and it's beneficial. It makes your career path easier, and also to transition to other programs that AWS offers. Like if you want to be a developer, you can be able to transition because as a solutions, I know two programming languages, which makes it easier for me to look at things at a developer standpoint, and then at the same time look at it at a managerial point of view as a solutions architect.
So, as a deep thinker, as a person who understands the architecture, cloud architecture, and understands about the cloud services, and know which one suits for the requirement. What do you say about my video series? Have you seen any videos of mine on YouTube?
Well, yeah, I think I did. I didn't see on YouTube, but I saw in LinkedIn when you are interviewing. There is a lady you are interviewing. Yes. Yeah, this is pretty amazing. It's pretty new, and actually, I never thought about it. I never thought about it like pretty cool idea. Like, because most of the time we know about interviews that have to do with jobs, um, other things that are not related to work, basically. But this interviewing people in different professions, that's pretty interesting, and I'm looking forward to seeing a lot of these. They are pretty motivating.
So, thank you very much, sir, for giving me your valuable time and spending some valuable information here.
Okay, yeah. So we can schedule time. I don't know. I can. You can inbox me because we are connected in LinkedIn, so that shouldn't be hard. And we can schedule time to do the second part of this, and that should be more practical.
Yeah, I will message you on LinkedIn again. So do you have any websites or any apps or any blogs of yours? Links I will put in the description of this video. People who finds our video on YouTube, they will find your links. Anything.
Well, I have LinkedIn right now. I haven't gone deeper, but I'm going to start creating a profile that has something to do with where they can connect and find me.
So can I put your LinkedIn profile link in the description of this video?
Yeah, that's fine.
Okay. Keep doing what you love. We'll meet in the next session again with
Okay,
the
thank you.
practical one.
Good to see you again. Sorry.
Yeah. Can I put this video and audio clip on my YouTube channel, social media, internet, podcast, website, everywhere with your permission?
Yes, that's fine.
Yeah. Thank you. Thank you again.